Game development can seem very complicated for beginners, but the truth is that it's not as scary as it looks. There's just a lot of information to take in and a lot of different things to understand. We are lucky enough to be using game engines today to make games, and most of the work is already done for us. You don't need to know any advanced math or any other super skills to create video games in most cases. In this video series, you will learn how to use Unreal Engine at a decent level. Everything from blueprints to code your game, how to navigate through the engine, add characters, and give them life, basic level creation and game design, creating basic particles and effects, and much more. Everything here is for free, no course, no Patreon, nothing. Just a bunch of free information. No previous game development experience required, no programming experience required, no designing skills, nothing. But you should know a little bit about computers. It's not a requirement, but it's recommended. Before you start using Unreal Engine, or any other game engine for that matter, there are certain things about games and game development you should know. I don't expect you to remember everything you see in this video, or in the entire series for that matter, but with time and practice, things will come together. I will explain everything in as much detail as I can, so that you will understand. So what does a game engine actually do? Well, it simplifies many things that would take a very long time for us to do, like handling the graphics, rendering, advanced math like calculating gravity, physics, etc., applying proper lighting, and so on. Unreal Engine also comes with an animation setup, particle setup, pre-made code, and many things that we don't need to do from scratch. So now that we know what a game engine is, it's time to learn some of the most common things. Some of the most commonly used terms are mesh, texture, material, input, collision, skeletal mesh, vertices, edges, face, actor, pawn, class, scene, object, compile, build, UVs, LOD. It might sound intimidating, but throughout the series it will make more sense. Starting off with geometry, vertices, or singular, vertex, acts as a corner where edges meet. An edge is a straight line connecting two vertices, and a face is a flat surface that forms the actual surface that you see when you look at a 3D model. A face is formed by three or more vertices connected by edges. All geometry consists of these vertices, edges, and faces. Once you have put together some geometry, it becomes a mesh. A mesh is a very commonly used term and is essentially a piece of geometry in your game. Things like trees, rocks, cubes, hats, characters, weapons. When you have a character in your game, you will need to give it a skeleton, also known as rigging. This means that you will need to give it a skeleton. If it's a human, you give it arms, legs, hips, so that you can animate it. It is known as a skeletal mesh. If a mesh in your game doesn't have any special properties, it will be referred to as a static mesh. Every mesh in your game needs to have a look, a color, and a texture. Textures are typically 2D images like, for example, JPEG or PNG. In order to put 2D images onto 3D models, you will need to wrap it around the model, kind of like wrapping a gift box. But in order for the textures to be properly aligned with the mesh, it will need to know where to go on the mesh. This process is known as UV mapping, which is essentially flattening the 3D model, kind of like flattening a globe into a map. When you put multiple textures together, you get what's called a material. A material consists of one of multiple textures that define how your mesh will look in-game. A material has different settings that you can adjust to make it look a certain way. For example, metallic will make your mesh look more like a piece of metal. Diffuse is the main texture of the material, and normal map is what's used to give the texture depth. When you place things in your game environment, like a rock for example, you will need to give it a way to interact with your character. So if your character overlaps with a rock, the rock will prevent the character from going through it. In order to do this, we need to use something called a collision. Collisions are a very important part of game development that are used to determine what should happen if things overlap, kind of like a decision system. So if you had a pit of fire, you could set the instructions to be, if character overlaps fire, take damage, or if you overlap a coin, you pick it up. When you create a game, you have levels. These levels can also be referred to as scenes. Your game is essentially just one big movie, and every part of your game is a certain scene. Things in your scene, like characters in your game, enemies, or maybe a car that will later explode, are known as actors or objects, things that you can interact with in some way. See what I did there? Actors can also be referred to as objects. The main difference between actors and object is that an object can be anything in your game, whilst actors have interactable properties. Every scene in your game needs to have proper lighting, correct shadows, realistic graphics, and so on. These calculations are handled by shaders. A shader is a computer program that determines how pixels, vertices, or fragments of a 3D model should look when rendered on the screen. Shaders are used to control the visual appearance of objects in terms of lighting, color, texture, and other effects. In order for everything to come together, you need to render the game. Rendering is the process of generating the final visual output from a 3D scene or model, turning the data like 3D geometry, textures, lighting, and shaders into 2D images or frames that you see on the screen. It's the final step in bringing all the components of a 3D scene together, making it visible in a game or animation. Rendering involves calculating how light interacts with surfaces, how textures are applied, and how the camera views the scene. When you write code for your game, you need to compile the code before testing it. When you compile code, you make the code understandable for the computer, because computers don't understand the programming languages that we use. Instead, the code is translated into binary. Compiling also optimizes the code for performance by making it more efficient for the specific machine it will run on. Checks for errors in the code, like typos, incorrect use of variables, or broken logic. When your game is complete, you will need to build and package it. Building refers to the process of assembling all the parts of a software project and generates the final executable or output that can be played. This is how game development works, and there's a lot more to it. But this should be enough for you to start your journey into game development with Unreal Engine 5.